Hey guys, welcome back to Eureka, and in this video we're going to be continuing the periodic of mechanics on week 11, chapter number 4, basic questions. I'm going to be skipping the definition questions like question number 1, question number 2. They're asking for the definition of things, so I'm going to skip that. And also the past paper questions, I'm going to skip those as well. So let's start. Basic question number 3. A ball is released from rest at a certain height. What is the velocity after falling 2.56 meters? Okay. Ball is falling downwards from an initial height. So g is 10 meters per second squared, and it's positive since the ball is falling downwards. And since it's falling downwards with no action of any other force, it's UARM. Thus, v squared minus u squared is equal to 2a delta x. U is 0 since the ball started from rest, so v squared is equal to 2a delta x. Thus, v is equal to the square root of 2a delta x. In other words, v is equal to 2 multiplied by 10 multiplied by 2.56, and that should give you 7 meters. Question number 4. A ball is thrown upwards with an initial velocity of 30. How high does it... A ball is thrown upwards with an initial velocity of 30. Number 1, find the maximum height. Number 2, find the speed after 4 seconds. Number 3, find the height after 4 seconds. So, to find the maximum height, well, we know that v squared minus u squared is equal to 2a delta x, right? At the maximum height, when a ball is thrown from here to here, at the maximum, the velocity is equal to 0, and then it starts going downwards, right? It decreases velocity until it reaches here, and then the velocity starts to go down, right? So our final velocity is 0. In other words, minus u squared is equal to 2a delta x. Since the ball is going upwards, g is negative 10. In other words, minus u squared is equal to over 2a is equal to delta x, right? And that should be our maximum height. Now u is equal to 30, so minus 30 squared, I said squared. In other words, minus 900 over minus 20, since a is negative, is equal to delta x. Negative and negative cancel out. 0 and 0 cancel out. 2 and 90, you get 45 meters is equal to delta x. Great. Part number 2, find the speed after 4 seconds. We know in UARM, v is equal to AT plus u, right? A is minus 10t, A is minus 10, then you add the time, and then you have u as 30, and that's equal to the velocity. They're telling you find the speed at 4 seconds, so let's just substitute 4. The problem is they use speed and velocity interchangeably, which is sometimes wrong, sometimes correct. Final speed is minus 10 meters per second. Part 3, find the height after 4 seconds. Well, we know that delta y is equal to half at squared plus ut. We also know that a is negative since the ball is thrown upwards, so minus 10 over 2 is minus 5. You have t squared plus u is 30, and you have the time. And then they're telling you find it after 4 seconds, so it's going to be minus 5 into 4 squared plus 30 into 4. This equates to 120, this equates to minus 80, and you subtract those, you get 40 meters. Great. Question number, we're going to skip the past paper questions, the ones that have January, the ones that have dates. These are all past papers. So let's go to basic question number, actually basic question number 7, I'm not going to solve it because I already gave you an equation for trajectory in my previous video, the video that says projectile motion video. Go watch it. You need to watch it before watching this video so you can know all the equations of projectile motion. Great. So let's go to number 8. A shell is shot with a velocity of 120 at an angle of 40 with the horizontal. So angle of 40, and it's shot at 120 meters per second, right? They're telling you find the maximum height. Maximum height, which is delta y max, is equal to v0 squared sine squared theta over 2g. In other words, 120 squared sine squared 40 over 20. Using a calculator, that should give you 297.5 meters. That's part 1. That's part 8 done, which is part 1. Let's go to part 2. Find the Find the time taken for the shell to reach its initial level. What does it mean for a shot to reach its initial level? It means that it's at the origin. When it's at the origin, the displacement is 0 on the y direction because it went up, then it went down back to its original position. So 0 is equal to half at squared plus plus sine theta v0 t. We derived this formula in the projectile video, of course. So sine 40 multiplied by 120 multiplied by t is equal to 0. We need to find the time now, so all we have to do is plug it in to the calculator. So we get two times. We get 0 and we get 15.42. Of course, we ignore the 0 because we don't want it. We don't want this point, we want this point. And this point corresponds to, 15.42 seconds. Let me take a sip of my drink. Thank you for that. Let's move along. Basic question number 9. A ball is thrown with an initial velocity of 15 at an angle of 50 with the horizontal. Angle of 50. Velocity 15 meters per second. Find the time taken to reach the maximum height. Well, we want to find the time taken to reach this height. Well, that's great. How I would solve it is, I would solve it in many different ways, but here we go. I would solve it is, we know that delta y max is equal to, v0 squared sine squared theta over 2g, right? And they want the time when you're at this point, right? So v0 squared sine squared theta over 2g is equal to, we also know that delta y max is equal to half at squared plus ut, right? So all we need to do is substitute the values and find the time. So what's v? V is equal to 15. So 15 squared multiplied by sine squared 50 over 20 is equal to minus 5t squared plus u in this case is sine theta v0. Again, we derived that from the projectile motion video. So sine 50 multiplied by 15t. Now we literally just need to find the time. So let's do this. Give me a second. I'm going to input this into a calculator. I'm breathing heavily. I'm sorry because, drinking lemon juice is not the best thing to do right now. Great. Okay, so sine 50 times 15. And of course, we're gonna get, let me just go back here. One second. We're gonna get 1.16 seconds. This is not what they got. They got 1.15 seconds. So I'm gonna show you the way they did it. So the way they did it is at the maximum height, the y component of the velocity is 0. That makes sense because if you're at the maximum height, your velocity is 0, right? So Vy is equal to 0. We also know that Vy is equal to sine theta multiplied by V0. And so if we take the positive direction to be upwards, we also know that Vy is equal to V0 sine theta minus gt. We also derived this in the previous video. It's literally like saying at plus u is equal to v, literally. So when you're at y max, this equals 0, right? So your final velocity at y max equals 0. So 0 is equal to v0 sine theta minus gt. Now g is 10, v0 is 15, sine theta is sine 50, and we literally need to find the time. So here we go. The time is equal to 15 sine 50 over 10. Using a calculator, we should get 1.15 seconds. There we go. You can also use my method. My method is longer and it yields inaccurate results. So here we go. You see, it's quite ironic. Here we go. People don't depend on me. I am one of the most ignorant students in this school, I believe. So let's do this. Basic question number, let's see, number 10. A ball is thrown from the top of a building 35 meters high. Initial velocity is 20. So you're at 35 and you threw the ball. It goes like this, right? Well, great. Now they're telling you, and of course it's making an angle 30 with the horizon and its initial velocity is 20. Part A, they're telling you find the time taken for the ball to reach the ground. So if the ball is at the ground, so it's here, so it went downwards, right? If upwards is the positive sense, so your displacement is negative, so your displacement is negative 35. We know that delta y is equal to minus 5t squared plus sine theta v0t. In this case, delta y is this distance, but since upwards is the positive direction, it's going to be negative, so minus 35 is equal to minus 5t squared plus sine 30, v0 is 20, multiplied by the time, input this into a calculator, and let's find the time. So here we go. Let's go back. Let's put 35. We are going to get about 3.8 seconds. We ignore the other answer because it's negative. Part B. They're telling you find the speed at which the ball hits the ground. Now, how do we know what speed the ball hits the ground at? Well, let's go back to this. We want to find the speed over here, right? Well, we have to break it down into its components along the x and y plane. So we need to find Vx, we need to find Vy, of course. So we know that Vx is equal to cosine theta V0 always. We also know that Vy is equal to minus gt plus sine theta V0. We also derived those previously. So all we need to do is find these two values, right? If we find this vector and we find this vector, we can find this vector's magnitude by the Pythagorean theorem. In other words, Vy squared plus Vx squared, and this should equal to V, or the magnitude of V, if you will. So here we go. We know that Vx is always constant. It doesn't depend on time. It only depends on the cosine and V0. V0 is 20. Cosine is cosine 30. In other words, it's equal to 10 radical 3. Now, Vy is equal to minus gt, which is minus 10t, plus sine 30 multiplied by 20. Sine 30 multiplied by 20 is just equal to 10. And the time is 3 point, sorry, what's the time equal to? 3 point, where is it? Yeah, 3.8. Time is equal to 3.8, so we're going to get minus 10 multiplied by 3.8 plus 10. So Vy is equal to minus, let's see, minus 28. Vx is equal to 10 radical 3. Using a calculator to find the magnitude, we need to find Vx squared. We need to find the Vy squared. We need to put them under a square root, and that is going to give us 300 plus something. And we need to square root that. We get 33 almost, or 32.9. No, actually we get 33. Yeah. Answers may vary due to, inaccurate rounding. Of course, let's go to basic question number 11. A plane is moving with a velocity of 55, right? At an altitude of 750. Okay, above the ground, when the bomb is dropped from the plane, find the time taken for the bomb to reach the ground. So the plane is flying like this, and then the bomb is dropped. I'm pretty sure this is a reference to Hiroshima or Nagasaki, because why not? Let's include some history and physics. So let's solve this problem. Let's see. A plane is moving with an initial velocity of 55. So your velocity here is 55. And we need to find this angle. Let's see. Find the time taken for the bomb to reach the ground. Let's see. So its initial angle is 0, and then it starts to fall and fall and fall and fall. So let me just read this. They want us to find the time until the bomb is thrown downwards. So here we go. We know that delta y is equal to minus 5t squared plus sine theta v0t. We know that this is minus 750. We know that this is minus 5t squared. We know that sine 0 is 0, so this cancels out. Because as you can see, our initial angle is 0, and then it starts to, bend down, eventually bending down over here. So our original sine is sine 0, of course, multiplied by v0t. Sine 0 is just 0, so this goes away. So we have that t squared is equal to 750 over 5. In other words, t is equal to the square root of 750 over 5. Using a calculator, we should get, oh my god, I don't know how to use a calculator. Nice. We're gonna get 12.25 seconds. Great. Now they're like, find the horizontal distance that should be between the plane and the target before the plane releases the bomb. Great. Great. So they want us to find delta x, and delta x is equal to v0 cosine theta multiplied by t. Also, we derived this in the projectile motion video. Now we found the time, and the time is 12.25. So all we have to do is literally put down the numbers. So v0 is 55, cosine 0 is just 1, and the time is 12.25. Our answer should be 673.75 meters. Now you guys are going to tell me, why did you sine 0? I already said it. And cosine 0, well, let me tell you. The plane is moving like this, right? And then all of a sudden, so you have the plane like this, then you have the bomb attached to the plane. It's moving like this, and all of a sudden, the bomb just drops. So it goes like this. So your initial angle over here is actually a straight line, so 0 degrees, right? So yeah, so sine 0 is 0, cosine 0 is 1. Let's move along to the next question. Basic question number 12. A ball is thrown from the origin with a speed of 30, making 30 with the horizon, and then given that it clears the top of the wall from a horizontal of 20 meters from the origin. Here we go. So we have this, we have a ball, it makes an angle of 30 with the horizon, and of course it goes at 30 meters per second, and then it clears a wall that is at some 20 meters, somewhere over here. There's 20. I don't know where the 20 is. We're going to figure it out. So here we go. The first thing is we need to draw the diagram. Now, how do we know where to put the wall? Either we put the wall over here, or we put the wall over here, right? Or we put the wall over here. But how do we know? Well, first of all, let's start by finding the range. Let's find the total distance, right? How do we find the range, which is delta x max? Delta x max is equal to v0 squared sine 2 theta over g, right? And your initial velocity is 30. We square that. Sine 2 theta is sine 60 over 10. So let's do it. 30 squared, 225 meters. So our range is 225 meters, which is quite a lot of distance. So I'm just going to make sure I calculated that properly. Of course I didn't. It's not 225, it's actually 78 meters. So let's see. Give me a second here, let me think. I think I have an idea. Let me just have 2 more seconds. Right, so I think I have an idea. Here we go. So 78 meters. That's our range. So our midpoint over here is 78 over 2, right? And that's equal to 39. If this is 39 and the wall is 20 meters away, that means the wall is somewhere over here, not here, right? So let's just erase all of this, and we just drew our diagram properly. Okay. So what do they want us to find? So the wall is at 20 meters from here, and they're like, find the height of the top of the wall, given that it just literally clears the wall. So it's tangent to the wall when it passes by it, right? So how do we do this? We know that, so look here. You know that delta y is equal to minus g over 2v0 squared cosine squared theta. We know this from, again, the projectile motion video, delta x, right? Okay. There's delta x squared over here, of course. Now we have delta x, which is 20. We have cosine, we have v0, we have g. All we literally have to find is delta y, which is the height of this. So let's just substitute into the equation. Delta y is equal to minus 10 multiplied by delta x squared, which is 20 squared, which is 400, over 2 multiplied by 30 squared, which is 900, multiplied by cosine squared theta, which is just cosine 30 squared. Cosine 30 squared is equal to 3 over 4, plus tangent of 30, which is 1 over radical 3, multiplied by 20, right? And now we can find delta y. Simply by plugging this into the calculator, we get 8.6 meters. So the height is 8.6. How do we know when do we use this formula? Well, they didn't give us the time, right? Okay, well, this formula does not relate to time in any way, shape, or form. So we just use it. And how do we prove it? Go watch the projectile motion video. Ta-da! Basic question number 13. A stone is thrown at an angle of elevation of 30. If 1 second later it hits the ground 1 meter below its projection point, find the speed of the projection. So here we go. So it does this, then our angle is 30, and then 1 second later it hits the ground 1 meter below the point of projection. So if here's the point of projection, oh, I'm sorry, I didn't draw this properly. So we're at 1 meter here. This is the point of projection. It falls over there because the point where it hits the floor is 1 meter under it, so it has to be above. And of course this angle is 30 degrees, right? And they want us to find the speed of the projection. Well, what is the speed equal to? The speed is equal to v0, and v0 is equal to, guys, I need to think about this question as well because I didn't prepare. It hits the ground 1 meter below its point of projection, the speed of projection. Okay, simple. So we need to find its speed. Its speed is just v0, right? We know that delta y is equal to minus 5t squared plus v0 sine theta t, right? We know that it hit the ground after 1 second, so we're, 1 squared is 1 and 1 is just 1. So we're left with this equation. We want to find our velocity, which is v0. We know that the distance here is 1 meter, right? And if it's thrown upwards, so it's going to be minus 1 is equal to minus 5 plus v0 and sine 30. So now we can find v0. So 4 is equal to v0 sine 30. In other words, v0 is equal to 4 over sine 30. 4 over sine 30 is equal to 8. So our initial velocity is 8 meters per second. Part 2, they're telling you the greatest height above the projection point. So they want us to find the maximum over here. How do we find the maximum? Well, You know how we find maximum. We use the equation v0 squared sine squared theta over 2g, right? So all we have to do is literally substitute v0. We just found it to be 8, so 8 squared, and sine squared of 30 over 20. Using a calculator, you get 0.8 meters. That's it. Moving on. Question 14. A gun fires a shell with an initial velocity of 770 with an angle 18 with the horizon. So here we go. Angle 18 with the horizon. What's it asking for? They want the range of the shell. Okay, guys, this is a dumb question. The range is this whole distance, and the range is equal to, so delta x max is equal to v0 squared sine 2 theta over g. Let's just substitute into the equation. 770 squared sine 18 times 2 36 over 10. On the calculator, you'll get 34388 meters, and that's your range. Basic question 15. A ball is thrown at 14 meters per second at an angle of 60. Find the velocity of the ball 1 second after its after projection, so after it's thrown. Okay, that's pretty simple. So if we want to draw this, it would look like this, right? They want us to find the velocity of the ball 1 meter after it was thrown. Well, how do we do that? We know that velocity is made out of its y component and its x component, right? Its x component is always constant. Vx is always equal to cosine theta, v0. We know that vy is equal to minus 5t squared plus sine theta, v0t, right? They want us to find the velocity after 1 second, so the time goes away because they said 1 second. 1 and 1, they're just weird numbers. So all we have to do is substitute into the equation. So let's substitute here first. Our initial velocity is 14 meters, so we get 14 multiplied by cosine 60. And of course, cosine 60 is half, so you get 7. And here Vy is equal to minus 5 plus sine, 60 multiplied by V0. V0 is just equal to 14. And we can find Vy at that specific moment. No. Did I go wrong? 1 second. Yes, I went wrong. I'm sorry, guys. I'm sorry. Quite glad I realized. Vy is equal to sine theta v0 minus gt. This is the velocity. If we wanted to say minus 5t squared plus sine theta v0t, this would be equal to the displacement. So no. Yeah. Now let's substitute into the equation. We get sine 60, v0 is 14, minus 10, multiplied by the time, which is 1 second. So we forget about it. So sine 60 times 14, and we subtract the answer from 10, we get 2.21. That's your Vy velocity, and your Vx velocity is 7. All you have to do is say 7 squared plus 2.12 squared, and our answer should be, yeah, about, I got 7.31, and that's what they got, 7.31. And yeah, that's it. Basic question 16. The top of the tower is 10 meters above the horizontal ground. A boy is on top of the tower. He throws a stone catapult at a velocity of 12, angle 30 below the horizon. How far from the foot of the tower does the stone hit the ground? Well, here we go. Let's just draw this. You're at 10 meters above. You throw a catapult and it hits the ground over here, right? Okay. The distance from the foot of the tower to the ground. So you want this distance. In other words, they want us to find the range. Well, how do we find the range? You can't really find the range in this case. You can only find, you can only find the range up till this point, right? But here you'll actually have to figure it out yourself. So we're not going to do that. The easiest way to do this is to say we want to find our, distance at the end. So delta y is equal to minus 5t squared plus sine theta v0 t, right? And we know that delta x is equal to cosine theta v0 t, right? So how many seconds? They didn't give us the seconds, so what we have to do is find the time. Yeah, exactly. So let's find the time. So delta y is minus 10, and that's equal to minus 5t squared plus, so sine theta, in this case, theta is equal to 30, so sine 30 multiplied by our velocity, which is 12 meters per second, which is just equal to 6, and yeah, sorry, plus 60, and let's just find the time using the calculator. So minus 5, 6, and 10, we're gonna get 2.13 seconds. 2.13 seconds, so we can actually substitute the time here and we can find the total range that we've traveled. Yeah, so what we've done here is we figured out the time by knowing that the displacement on the y-axis is equal to minus 10, so we can find the time from this equation. Man, my phone is ringing. And then you just have to substitute 10, so yeah, cosine 30 multiplied by v0, which is 12 multiplied by the time, which is what we just found, and that should give you your answer, and that is 22.21. So let's actually solve this on the calculator just to make sure that I'm correct. Guys, forgive me for my dyslexia because I am not focusing with anyone right now. Basic question 17. A stone is thrown from the top of a cliff with an angle alpha above the horizon with a speed blah 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 blah. The stone falls into water, which is 37.5 meters from the foot of the cliff. Given that tan alpha is 12 over 5, blah 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 blah. Great. What do they want us to find? They want us to find the height of the cliff. Okay. Thrown like this. This is not found. We don't know what this is. Tangent of alpha is equal to 12 over 5, and they want us to find the height, this whole thing. We know that delta y is equal to, minus g over 2 v0 squared cosine theta x squared plus tangent. In this case, it's not theta, it's actually alpha. Tangent alpha delta x. Well, we know that delta x is 37.5 meters because the stone falls into the water below it from the cliff. So from the foot cliff, so the water is over there, 37.5 meters. So all we can do is literally substitute into the equation. My question is, how do we find the cosine of the angle in this case? Let's see. Simple. We know the relationship between cosine and tangent. In other words, this is cosine squared. So how do we rewrite this? We get minus g over 2v0 squared secant squared alpha plus tangent alpha delta x, right? The tangent is given. We know that 1 plus the tangent squared is equal to the secant squared alpha, right? So if we square the tangent, we're going to get 144 divided by 25, right? And if we add 1 to that, we should get the secant squared. So the secant squared is equal to 169 over 25. And that's equal to the secant squared of alpha. So now we literally substitute into the equation. You get minus 10 to v0 squared. Our initial velocity is how much? 19.5. We square that. We multiply by 169 over 25, and we add the tangent of alpha, which is 12 over 5 given in the question, and we multiply that by 37.5, which is, of course, and yeah, I forgot to multiply by that there, 37.5 squared, and that should be equal to your delta y. Do that on a calculator, and it's equal to, 35 meters approximately. Just gonna, let's see. I'm going to do question number 18, and well, the rest is the same. So question number 18. An arrow is shot from the top of the building, which is 26 meters high. The initial velocity is 30 meters per second. Find how long the arrow is in the air if it's fired at 20 below the horizon. Okay. How long is it in the air? In other words, it's thrown like this, right? In other words, they want us to find the time at which it's in the air, so they want us the time until it reaches the ground. How do we find that? Well, pretty simple. Delta y is equal to minus 5t squared plus sine theta v0t. If it reaches the ground, that means delta y is equal to 0, so minus 5t squared plus sine theta. Theta is 20, so sine 20, our initial velocity is 30 meters multiplied by the time, and of course now we just need to input this into the calculator. And it's about, let's see, how much does that give us? Oh no, I forgot to tell you guys, well, I drew this wrong. Let me redo this. It's actually 26 meters high, so it goes like this from 26, and then it reaches the floor. So it's actually minus 26 is equal to minus 5t squared plus sine 20 multiplied by v0, which is 30 meters, and the time, and of course use a quadratic calculator, and you'll get that the time is equal to 1.47 seconds. There you go, that's your answer, and thank you guys for watching, and as always, easy. Come back next time, I guess.